Hello, everybody, and welcome back. So today we're going to be focusing on calculating the percent water, okay, in a hydrate. So if you remember from yesterday, what a hydrate actually is it's usually a salt with a crystalline structure, and within that crystalline structure there are actually water molecules that kind of help build the structure. So we are going to learn how to calculate the percent of water by mass in this hydrate. Now, this is basically the same thing as percent composition. So you're going to find the mass of your salt, you're going to find the mass of your water, and then you're going to take your water divided by the total mass of everything. It's the exact same thing. So you want to make a note of that on your sheet. It's going to be the mass of the water divided by the total mass. All right. And then that whole thing times 100. That's going to give you the percent water. And again, it's the same thing as percent composition. So it's the same thing. We're just looking at water as kind of its own thing, like a whole piece, instead of looking at the individual elements. So let's do this. So to make this a little faster, we're going to look at MgSO4 as a whole first. I'm not going to go through how to find the mass of MgSO4 separately. You've already done that. It's just the molar mass. So we want to find the molar mass of MgSO4, or magnesium sulfate. All right. So I'm going to add up all the masses of all of my elements in there. So I've got magnesium plus sulfur plus oxygens, 4 oxygens. The total mass there is going to be approximately 120 grams. Now, I am going to round for these. It's just going to make it a little bit easier. I'm going to round to the nearest whole number. Again, this is a lot of math. I want to make sure that everybody is capable of doing this. So if you do not want to round, you do not have to. So do what you got to do. All right. Now, for water, you're going to notice that there's a coefficient here, 7, right? What that means is that there are 7 water molecules. So we have to count that when we do this. So water is normally 18 grams, is 1 water molecule, the mass of 1 water molecule, right? Molar mass. I'm going to have to times that by 7 to get the total mass of all of the water molecules here. So in this situation, right, when I do this, it's going to be a different number, right? It's going to be 18 times 7 rather than just the 1 molecule, which is 126 grams. Okay? Now to find the total mass that I need here, I'm going to add these together, right? So I'm going to add those two masses together. I should get 246 grams. Okay? So again, if you notice what I did, I took 120 and I added 126, all right? So I added these two. So this is the total mass of this entire thing, right? Now I want to find the percent of water. So what I'm going to do is I'm going to go over here. My mass of my water is here, all right? I'll even circle this and label it, all right? So there's your mass of H2O, right? This is your total mass of the whole hydrate. So to plug it into this formula, I'm going to do the mass of my H2O, which is 126 grams, divided by the total mass, which is 246 grams, right? Then I'm going to take whatever I get for that answer times 100. Okay. Now, if I plug this in the calculator, and I will do this for you so that you can watch me, okay, I'm going to do 126 divided by 246. All right, equals, and then I'm going to do times 100. Some calculators make you hit equals, some don't. I would always hit equals before I multiply by 100, just because if you're using a regular scientific calculator, it will actually give you the wrong answer. It will only multiply the second number. So just keep that in mind, right? Please do not use this. We don't need fractions. This is science. We use decimals. So 51.21219, blah, 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 blah. I'm going to round it to the second decimal place. 51.22 then is going to be my answer. So my percent water is going to be 51.22%. And that's my answer. All right, so again, you'll notice it's very, very similar to percent composition. The only main difference here is we're looking at each of these as kind of an individual, and then we're looking at the percent of water compared to the entire hydrate total, right? Not too terrible. Why don't you try some of these out? Please make sure you do show your work as I have, right? Go through this video step by step. If you get most of them done on your own, I will post an answer key next week. So again, once this week's work is submitted, I will post an answer key so you can check your answers, kind of go through. Email me if you feel like you need some help, and I hope you have a wonderful rest of the day. Thanks, guys.